Okay, these are very big fonts. We'll be using the rest of this later. Thank you for giving me the title of the presentation. It actually really helps. The titles are the hardest part sometimes.
Yeah.
I want to give you an about me. I think it's important to understand why the people that you are listening to have any credibility if they do. If I have any credibility, it's because I've been doing this kind of stuff since about 1998
Oh,
when I
and Wes, sorry
was,
to interrupt.
yeah,
Maybe you could go full screen because it's kind of small on some devices.
sure.
Yeah,
Better?
that's much better. Thank you.
Okay. So this is me around 2001 when I was in college, water cooling a piece of junk machine that I had that eventually became my first home lab machine back before there was any public cloud. So what I do today is I run a team of cloud engineers, software developers, operations specialists that ship a SaaS product that actually you might be one of our customers and not know it. It's called Banner. It's made by Ellucian. Um, Previous to that, I ran the SaaS portfolio for a company called Rosetta Stone, language learning company. So I've done worldwide, I've done hyperlocal, I've done AWS, GCP, Ali Cloud, and some Digital Ocean, which is specifically for team up, actually. Um, DigitalOcean is fun, and that's the demo we're going to be doing today. But what I'm here to tell you about is how I'm going to say in air quotes because I'm talking about myself, how professionals do continuous delivery and deployment integration, how we ship code to real non-prod and production clusters to deliver to people. This is an overview and it's only one way to do it. And so if you have questions, by all means, reach out to me however you want. Uh, I love talking about this stuff. I'm a huge nerd. So I wanted to first talk about the three kind of what I would consider the pillars of delivering code to production, and then point out how the maturity level for those things increases as you go along. So years ago, we came up with this idea of continuous integration, which is for continuous integration, you would have quarterly or half yearly or yearly software releases. People would just make these gigantic plans. I mean, hundreds of pages of plans for the functions that got delivered, the features that were going to make it for 2008 or whatever, the features that were going to be pushed to next year. You would go through this giant process of fighting with your development teams and your product managers to figure out what went in because you had to ship a CD-ROM, right? You had to ship a physical device and it had to work. And then as we moved into internet delivery, which eventually became SaaS, people realized that you could ship code in much smaller blocks. And we started shipping in smaller and smaller and smaller blocks down to, we'll routinely ship a 5-line change to production, right? Which is fairly easy to do. So what we went into as an industry is this idea of continuous integration. And as you release a change, hopefully a small change, but sometimes a gigantic one, you ship it into your source code repository, and then there's all of this automation on the back end. And it integrates it into your platform, but it doesn't necessarily do anything with it yet, except to maybe run tests. So the first advantage here is you're sitting at your laptop and you do your local testing, you commit it, some automated process pulls your code in, integrates it with the overall thing, which might be thousands of files, source code files, right? Or it might be 10. And then it runs through tests. And as the industry got better at that, we started to come up with best practices, or maybe at least slightly better practices. I don't know that we have a lot of best practices, but one of them is using a branching strategy in Git. The most popular one probably is called Git flow, but it's when you're using Git, you say, all right, now I have the main or master branch, and I could have a production branch, a test branch, or I could use features. There's a lot of different ways to do it. But largely the idea would be that when you ship a commit, it gets automatically tested. And so everyone got really good at this, actually, right? A lot of modern tooling, you can do this with Ruby or Python, JavaScript. Uncompiled languages are especially good at this because you can just shove it in there and then start running your tests. Once we got a little bit better at that, we realized that you could, if you trusted your tests, go ahead and ship that code into some sort of test environment. internally facing, right? And then you could have your QA teams do their tests, their human tests, smoke testing, integration testing, whatever you were doing. You can automate that. Right. And so what we would do, and this is continuous delivery is kind of when DevOps started coming into the forefront. So as DevOps engineers, what we would do is take this source code repository or hundreds of source code repositories and build a system to support creating shippable binaries, creating container images, creating virtual machine images, whatever we needed to do. Sometimes just FTPing stuff automatically to a server, right? Just whatever we needed to do to get it in the hands of the product managers, QA people, and the manager, right? Sometimes the CTO wants to see what you've been working on. And so you get it into an environment where it works like it would work in production. And then you kind of stop and everyone smoke tests and everyone has a giant meeting. And in the meeting, you decide, hey, is this thing working the way that we want it to work? Yes. Okay. You get a whole bunch of people signing off on it, and then you ship it to production. And at this point, before we moved into continuous deployment, you generally would not ship things to production automatically. There was a human involved, there were change tickets, there was a whole bunch of either you would want to say useful control or useless bureaucracy, depending on your kind of view of it. But eventually we got better at that too. And you can say, all right, well, if QA is signed off on it and our automatic testing has worked and it works in non-prods, why don't we just ship it? So then we spent probably a half a decade really aligning on the best kind of practices to do continuous deployment. The third CD, and I'll be clear, continuous deployment is still pretty rare in the industry for anything that's a significant project, right? It is very much a startup mentality. If you have a huge code base, continuous deployment often just doesn't work. Can't do it because you still have thousands of people working, or hundreds or thousands of people working on a code base of some type, and you may have like our primary product was very recently, within the last 2 years, we've removed all the COBOL. If that gives you a sense of how long enterprise software can take to change. But if you're writing a startup app, right, you can put it into continuous deployment pretty easily. And so what you just say is, all right, let's eliminate the bureaucracy. Let's eliminate the check marks. We're going to ship small code changes, like one function, maybe 100 lines. And the goal is to go from a developer's desktop to production in a week instead of a quarter or a half year. And then it got to be 3 days. And then it got to be a day. And then it got to be 5 minutes. And you start living in this world where someone tests it locally on their Docker container, ship it to Git, and it's in production by the time they get back from coffee. That is the kind of like the apex of the industry standard right now. And I don't necessarily push for that, but I think for a lot of the projects that you folks will be working on, you can do this because you can control the quality of the code that you ship much more easily than you can a giant enterprise resource planning system, right? So there's 3 things to point out here. When you start delivering to production as opposed to your pre-prods, you don't really care about them the same way, right? Customers are paying you to keep this stuff online. And once you've got the 17 layers of testing or whatever that the company has decided that you need to ship, then you start taking sort of different tactics in how you release software. So a feature flag is a critical thing to do. A feature flag is effectively when you write a new feature in your code, you add a Boolean check to see whether that feature is enabled or not. And you default to disabled. And so you can ship that thing into production and not care about necessarily whether it works immediately because you shouldn't ever be able to execute that code path. Then you turn on the feature flag. If nothing explodes, you leave it on and your new feature is out. Blue-green deployment and zero downtime releases are tightly coupled. And the idea would be that you have a production system of whatever, maybe it's 10 computers or maybe it's 50 Docker containers, and they work as a unit. You ship all of the new code to a new set of Docker containers over here. And then you flip a switch and it goes from this side to this side. You leave the old side up. Once you're in production, if everything is working correctly, then you say, this is good. Everyone signs off and you tear the old stuff down to save money, basically. And you're now on your green side, and the green side is serving content to customers or whoever your audience is. And then the next time you want to ship a release, you spin the whole thing up again. That becomes your blue side. Swap all your stuff over, do the same process. And when this is fully automated, you can do it in 15 minutes. Works for databases, for zero downtime for databases, because one of the big challenges of delivering any real serious software is managing your database changes, whether it's relational database like Postgres or even Dynamo. If you have to change the backend database, there's almost always code changes that have to go nearly at the same time. And it becomes a QA nightmare if you have to have, like, say that you need to support Postgres 15 and Postgres 17 at the same time. Well, now you have two complete test sets that you have to maintain and run, right? So you don't want to be running like that for very long. Canary deployments are when you ship something to 10% of your customers, or let's say that 10% of your API calls go through a new code branch instead of the old one. And you have, theoretically, telemetry on both functions, and you know how often they fail. And if the success and fail rate is about the same, or the new one is better, and the return values all come back clean, then you say, great, they're fine. Go ahead and ship that Canary deployment to 50% of customers and make sure that it's still good, and then do 100%. You can still do this over, if you're a huge company, you can still do this over a day, right? So you're still shipping code very quickly, but you're also keeping in mind that Facebook had a mentality for a long time that move fast and break things. You can move fast and break things when your customer doesn't pay you. What Facebook never move fast and breaks is their ad delivery network. And that's just something to kind of keep in mind when you think about what does deploying to production look like. Move fast and break things in patterns that you can quickly recover from. I covered all of this fast because I think probably it's familiar to most of you, but I'd like to stop for questions about this specifically.
Yeah, there's a question in the chat from
Sorry,
Chad.
I can't see the chat.
Yeah,
So
so
Oh, it's not a very I put it in chat because it's not like a very urgent or interesting question. I just heard the reference to Cobalt and like the kind of older versus newer companies, and like I was just wondering if there's something about Cobalt in particular or older languages in particular that makes it more difficult to use CI/CD, or if it's just the difference between having like a 20-year-old code base versus like a new code base.
um, both, actually. A lot of modern languages, and I'll say, uh, yeah, a lot of fairly modern languages have been designed with the deployment in mind. And older languages were not, right? Because you didn't deploy it. There was someone who wrote the code and then they just copied the file to the server and then it ran, right? Um, and so not necessarily COBOL specifically, but you would have the same kind of problem with essentially any language that's older than maybe 2010, or at least hasn't had major updates. But in my specific case, what I was saying is, this is not meant to be an insult in any way. Since you're young and in school for the most part, I I don't know that you can comprehend how much bad code exists in the world, or how much just old code. It might not be bad. We should be clear. COBOL is an incredibly good language. It delivered business value for 40 years and still is delivering business value in a lot of big name like Social Security, right? Um, but it is not. You can CI/CD CD practically anything if you get smart enough people working on your pipelines. It can be done. But what I'm saying is a lot of times people are kind of stuck in this continuous integration phase or even below it because they are working on a code base that has so much tech debt that they can't deal with anything else. There's no way that they can get into this idea of we're going to move our non-managed code repository that's in circa 1997 Java into GitHub and then have, update all the code, right? They can't even run on a modern JVM, and this wouldn't be in their first kind of thing. Now, I would argue this is absolutely the first thing that they should concentrate on, because getting their continuous integration up and working means they can move to a newer JVM, they can move to new versions of Spring very quickly, but you have to have tests. I think that was probably a roundabout way of saying my point. There's nothing wrong with COBOL. It's just that enterprise software moves still, even though we're not shipping CDs or tapes. Enterprise software still is a glacial speed.
That makes sense, and it explains why I hear about a lot of teams that are like switching from Java to Go or something like that. I don't know. I mean, Java, I guess, does have a lot of good updates. It's probably pretty
Yeah,
deployable, but
they're probably switching for licensing reasons, if I had to guess.
oh, interesting. Okay.
But you can definitely continue to deploy Java. We do it. There's nothing about the Java ecosystem that prevents it. It is a
Oh,
little bit
gotcha.
tougher because it's compiled. So, one thing that you can do, let's say you're using Python and you want to continuously deploy Python, you can build your Python environment so that the web server restarts if a new file appears, or something like that, right? Depending on what you want your deployment to look like. With Java, you can't just shove a new class file in and then you have to restart Tomcat. There's downtime involved, so you have to coordinate more.
Yeah, that makes sense. Thank you.
Of course, it's a good question. I love talking about COBOL.
All right. Any other questions from the audience?
If I'm going too fast, please feel free to ask me to slow down or
Well,
speed up.
I
I
do
guess
have a question. Just can you explain? So, with code that has a lot of technical debt, how is that more difficult to have it become like continuous deployment? Can you explain that? Just like I feel like I don't understand why. I understand why like technical debt is a good problem, but why is it causing issues with this, and what does it do in the process?
Typically, it's because of how you have to prioritize the work that gets done. In the industry, the term is often tech currency. So let's say that you are 3 years behind on your JVM. You can either deploy humans to upgrade your JVM, or often those same humans would be doing your continuous integration pipelines. And it comes down to there are security vulnerabilities in old JVMs, and we fail audits because those are old. We don't fail audits because we don't ship to QA immediately. I probably misspoke or was definitely unclear. There isn't anything about tech debt that makes it harder. In most cases, there's nothing about tech debt that makes it harder to do CI/CD. I can come up with some contrived examples. Like if your database is really old and kind of decrepit, it gets a lot harder because there are modern tricks in databases that help with continuous delivery, but it's not really something in the language itself or tech debt itself.
So it's like the tech debt is the distraction from the CI/CD.
In
So
most
it's not
cases, I've seen
technically
yes.
okay.
Yeah, because you need the people who are good at continuous integration tends to be a little bit of software developer and a little bit or a lot of infrastructure. And typically the people who are dealing with most tech currency are those exact same skill sets. And so you only have so many of those people in any organization.
Okay. Thank you so much. I think I understand now.
Thank you for pointing it out. I think I said that either unclearly or misspoke. I don't remember my exact sentence, but yeah.
right. Any other questions? Okay. guess, Wes, we can move on.
All right. So why do we do this? This is going to be a brief one. CI/CD CD is proven to increase software and service quality, and I originally said in the slide scientifically, but I didn't like that term. However, there was a company called the DevOps Research. I don't think they're a company, but anyway, a couple of people did a massive survey of software companies from different sizes, 10 users to 20,000 developers, right? And they built out 4 metrics that kind of guide whether or not a company would be good at delivering quality software. And 2 of those are how long it takes to ship a change and how often you can deploy. And change lead time, when I first started in the industry, change lead time for software was months, years, because again, it had to be burned to a CD. And now for a very agile small company, lead time is often in the 15-minute range. And the reason that updates quality is because if you can ship it in 15 minutes, the amount of code that you have to actually ship is much, much smaller. There's no big bang at the end. There's no hundreds of people doing QA on a thing that you have to get to a factory to press 10 million CDs by Tuesday. And the deployment frequency is kind of an indirect measure, but it's the same sort of idea. If you can ship 50 deployments a week or 400 a month, then each individual deployment is not that important. So when you combine those 2 things, even if you ship a bug to production, you can fix it in 15 minutes. So I would encourage people to look into Dora, and if you're more interested in this from a narrative perspective, there's a book called The Phoenix Project that's actually pretty interesting. Anyway, ship smaller, test better, more frequently, ship to production 100 times a month. That is absolutely true. That was what Rosetta Stone was doing when I left. And we had 15 macro services that were all written in Rails. So roughly each one was shipping about we were shipping something 3 to 5 times a day on average to production. And it was fantastic. Because often it was a single function change or a database configuration change or something that was super easy to do. 0 touch, no one had to do any manual labor once it was committed. Okay, I'll go through this quickly, but this is just, I touched on all this, but an example workflow of how CI/CD works in real life. You have a dev team. Can you see my mouse? Does that work? Yeah. You have a dev team. They test locally on probably containers in the modern world. They're happy with it. They ship a PR. Their peers, to some degree, review it. And then immediately, once that's done, it gets continuously integrated into the test environments and delivered into the test environments where it's handed over to some sort of testing. It might be human QA teams. It might be automated. It's almost always a mix of both. It gets tested. Once it gets tested and they sign off on it either by clicking a box or by going to some meetings and saying everything's okay. Someone does something. They ship it to pre-prod. It all happens again. A QA team and customers sometimes, and automatic smoke testing happens in the pre-prod environment. And this is the important distinction because for financial reasons, test environments are often junk, like a single machine running Docker. But your pre-prod deployment should be almost exactly like production. So same database versions, same container versions, everything. It's probably just scaled down to save money, but it will be the same architecture. And then once you're happy with that, it ships to prod. When you've moved into continuous deployment, this testing gate often goes away. You ship it to pre-prod, you let it sit there for 5 minutes to 5 days, and then it ships to prod. But I think you can all see why that would be incredibly difficult to get to the point where you trust your testing to let you ship things to production without any human intervention. Because as soon as you ship bad code to prod, you're losing money. And then I just throw in some AWS stuff there because that's what a real production looks like, right? You have a database, probably a database cluster. You have maybe Kubernetes containers or something like that, or you're using built-in app deployer that sort of pulls all that stuff in together. You don't necessarily run your own ECS cluster. Sometimes they do it for you transparently in the background. But that is basically it. And I said, this is definitely not the only way. Whatever way that you develop works for you and lets you get quality is the way that works. Best practices, super simple. These are the things that really in the nuts and bolts. So the most important thing and the nastiest thing that people will do that causes you to scramble around to fix a disaster is to commit passwords or API keys to Git. Because as soon as that happens, someone on a security team somewhere finds out about it, and then you have to go change that thing everywhere. And you might have it in hundreds of places. Never ever commit an API key to Git. Never put a password. Ideally, anything that can change between a production environment and the non-prod and the testing should not be in Git. Or if it's in Git, it's in a separate Git repository that's specifically designed to build your infrastructure out. I would recommend people check out the 12-factor model. It's a little dated, but it's still fairly valid. They talk about how should you log, how should you feed environment variables, or how should you feed passwords in using environment variables, that sort of stuff. Just good to keep in mind. Database migrations, if you're using any type of database, not every app does, but if you're using any type of especially relational database, it's great and best practice to capture your database migrations as code. So let's say you add a column, you use one of these tools like Alembic or Active Record to add the column. And then when you ship that to wherever, your DevOps pipeline should apply those changes automatically into the environment so that they're still captured as code. And then dot files and env files for local testing. It's the same kind of thing as this, right? Don't commit secrets. Make sure they're in Git ignore. This is almost always a disaster if someone does it, which is why I have it on here twice. Don't treat the 12-factor model as gospel. Adopt it to what you need it to do. I happen to disagree with how they recommend logging. Don't run your staging on the environments on the open internet. This happens all the time. People don't care about their staging data nearly as much as their production data. And so they might have who knows what in their staging database. And if it accidentally gets exposed, it's at least embarrassing. And sometimes it can be illegal. If you expose accidentally EU customer data in your staging environment because of a bug, you're going to get called to the mat for it. And don't accidentally spend 10,000 overnight in public cloud. Ask me how I know. They were kind enough to refund it. But if you're not careful and you write your deployment loops wrong, you might spin up, 1,000 machines accidentally. And if you expose your AWS key through GitHub, you might have someone spin up $30,000 a day worth of Bitcoin mining gear in your AWS account. Don't ask me how I know that either. Both are true stories. Questions about any of this? I think these are the only one that I don't think is obvious is the part about environment variables, which is why I really emphasize it. The first thing people tend to do is shove their S3 API key or whatever into their source code so that it works easily. Resist that, because one day you will commit it. Even you're just going to forget, you will commit it. And then someone will have your keys and they can do things on your dime. At best, they charge you money. At worst, they get PII exposure. There's a lot of things, personally identifiable information. Sorry, a lot of bad things can happen. All right, we're at a half hour. Here's what we're gonna do. Let's second half hour. I wrote an incredibly, and Copilot wrote an incredibly bare bones Python Flask app. We're going to ship to DigitalOcean using their application as a service platform. So I have it kind of ready. I've done all of the parts of this, but we're going to go through it in real time. Please stop me if you have a question. I think a half an hour is plenty of time to do this, but it might fail and then I'll be embarrassed, but it'll be okay.
Yeah, and thank you, Wes. And by the way, I just noticed some students might not know what DigitalOcean is. I know AWS is pretty popular.
Oh,
Well, it'll be great
sure.
if you can just give them maybe a few seconds of what it is and what we use it for. Yeah.
Yeah. So there's there's like tier one public cloud, which is AWS, GCP, Azure, and they are typically the most expensive. DigitalOcean is a very cost competitive, but also very good public cloud platform. They have a great Linux CLI. They have great documentation, and they they will have what you need to run an application without a whole bunch of extra stuff. Um, TeamUp uses them. I guess this is still true. Broadly, we use them because it's less expensive and you can do a lot more quickly without having to worry about a whole bunch of AWS hidden costs. Just having an AWS thing running is quite expensive just for practically nothing. By the time you get networking and everything up, you're 50 or 100 bucks a month, and those add up pretty quickly. Whereas this app that we're going to deploy is going to cost about 10 bucks a month, roughly. So it's a public cloud platform. I encourage you to use it. It roughly competes with a Roku, um, but also they just have virtual machines and you could do whatever with it also. All right, fingers crossed. So I will show you what I wrote. So this is a very basic, I will zoom because I know that's terrible to read. This is a very basic Flask application. Flask is a Python web server, competes with like the Django, or it's similar to Rails. But I put in two routes for it. So when we spin up the web server, it's going to answer to slash, it's going to print hello world. And when I spin up the Postgres server, if we get to that part, it'll print something from a database. But my intention here is to show you how to deploy the DigitalOcean direct from commit to prod, right? Whole pipe. So I spun up a Git repository in the team up space called Wes demo app June 2025. And I am going to think, dev, yep. All right. So I'm not going to do PR. I'm following a certain Git flow pattern where there is a long running branch called development. And what we're going to do now is go to the DigitalOcean console and set that up to auto deploy. So what I'm going to be using is what they call, it's not App Engine, that's what AWS calls it. It is App Platform. So we go to the App Platform, deploy a new application. Let me zoom so everyone can see, especially people who are on their phones. And this is already set up in the background by a magic, but there's a permission stuff in GitHub that you may have to have set up for you. But I select the Git repo that I care about, and it checks with Git to pull the branches. Maybe. This normally takes about 1 second. So this is why you don't do live. There we go. And I've got development branch. I'm going to turn on auto deploy because it's development. And let's see if it proceeds. It did, great. So the first thing that it does, I have a YAML file, which I'll show you in a little bit. But the first thing that it does is detect that it's Python, which is nice. You don't have to do much with it. And then it tries to put you on a relatively expensive virtual machine. I'm going to put it down to a cheaper one because it's dev and I don't care. I don't need it to auto scale. It's going to say, this build pack ID is actually something they took from Heroku, but the Heroku tools are open source. This is from my YAML file that I will show you. This is what's going to run it, and it is not on 8080. 80. It is supposed to have detected that. I think it's going, there's another one. We might have to fix this later. And you'll see here, there's a point for environment variables. So what I was talking about with not committing your passwords to Git, which I totally just did if anyone was paying attention, is that you should put them in environment variables first. And we'll come back to that if we get to the Postgres demo. But I will do one just for the sake of having it.
Are you
So-
asking us not to hack it in the next few minutes?
No, feel free. I don't use that password anywhere else. It's like super pass 123 or something ridiculous. So I'm going to set an environment variable called we'll call it bb user test user 01, and then we will save that for now. I don't know if we'll use it later, but this is how you would set them if you decide to use them. New York is fine. SD display stuff. That's what I would name it in my own production. $5 a month. And then we hit create. So once we hit create, it pulls in my Git branch. It attempts to do some auto magic where it detects some certain things in the Python. But really, it's pretty straightforward. It will expose it, it will run the command that I gave it to start up, and it will theoretically work. This will take a while, though. If we look at the build logs, what it does is it spins up a container to compile your application, generates a new container, ships it to their internal container registry, and then it pulls that container and loads it. So right now, it's pulling in all of my Python dependencies that is going to take to load this stupid little website that I wrote in 5 minutes. But that's good. This is exactly what we wanted to do. While that's running, I'll show you a couple of the things that I did to make it work. So this is what I committed. I committed the cardinal sin of DevOps, and I shipped my password to GitHub. And I probably have a nasty gram from GitHub in my email right now about it, actually. Under the DO directory, they want you to put in a YAML file that describes what application you're deploying. And I just did the very kind of basics to get it to work. In fact, that's probably going to fail because that's not a valid key. Maybe it is. It's supposed to be. Yep. See, this is why live demos are broken. So if it fails, we'll auto ship it and we'll see if it fixes it again. This, as far as I'm aware, this app YAML inside of the .do directory and the proc file, which is the proc file is a specific file that's used by Heroku and DigitalOcean and other companies that offer the service to tell it some metadata file that tells it what to do. So in this case, I want it to run this command, right? That's going to start the web server that serves my $1 million startup app that I wrote this afternoon. There's a bunch of other Python stuff here that doesn't matter unless you're interested. Please feel free to ask me. And that is mostly it, I think, for what you would need for this. I did write a bash script for local testing. So I've got a Docker compose file. If anyone wants to check this out, it should be available to you anyway. Although you'll want to change some of the paths and stuff like that. And this is supposedly supposed to work, but it doesn't. I think it's up. Maybe? Not quite done yet. Right, we will go back. So my intention is to do a merge, right? And then see it automatically deploy. And then we'll go do a production workflow for the same kind of thing. And I will go through the create and what a production would look different. Like I won't spend $5 on production. It's going to be, oh, it failed. Excellent. How did it fail? Did not respond to health checks. Right. Why did it not respond to health checks? It's worked before, I promise. 1, 2. Oh. So I update the configuration to have the correct port, and it will automatically redeploy. Detects the configuration change. Should be faster this time because it doesn't have to make the container again. But, well, maybe it does. But basically, when you're using an app deployment like this, you can have a $5 or a $10 a month development environment. And just as soon as you click, as soon as you commit to Git, it'll fire off the deployment from the DigitalOcean side. So we have, in fact, implemented CI, CD, CD in the most sketchy way possible, I guess, for this demo. But I did smoke test on my local machine. I can run this thing. With that bash script. So it spins up my local Docker container, which is running a Postgres server, spins up Unicorn on 1, 2, 3, 4, 5. And if previously was down, then I can see hello world. That was my smoke test. It's very, very bad, but really for an application like this, you don't need heavy QA, right? I said as I build complete, deploy successful. Okay, now I'm going to send everyone a link via the Zoom chat. If I could find the Zoom chat. If you would hit that, please, you should get a hello world.
Yes.
It's on the internet. This still makes me nerd out. I just love it when this stuff works. So now what we'll do is we're going to change the app py to something else. Instead of hello world, it's going to be, what should it say? What does everyone want it to say?
Howdy.
Howdy. All right. 1 exclamation point or 5?
5.
Awesome. Do that every time. So now, if everything is working as expected, oh, look at that. Very quickly, it detects that there was a Git push and it's already starting to rebuild. So in about 2 minutes, hopefully that same URL will say howdy instead of hello world. While that's running, any questions so far? Okay. Then what I will do is we will quickly set up a way to do production. Actually, no, let's not do that. So there's 2 ways to do this. Some people advocate that you deploy from main, and some people advocate that you deploy from branch. I don't care, but what we're actually going to do is deploy from main so that I can show you the kind of workflow that we would typically use. So we're going to create a new app. And it's going to be more expensive. I promise I'll tear it down. Now, right now, it's going to completely fail from deploy from main because there's nothing in main. I have not done any merge in main, not even a readme, just to get it going. So we're going to go from main. We're not, probably don't, well, I don't know. You can choose to auto deploy or not on your own. I'm going to say not auto deploy because production is, even my smoke testing is not great. No component detected. All right, so it's failing because there's nothing there yet. That does in fact make sense. So what we will probably do do this by hand. So we are going to put in pull request to main. This is a terrible PR description. Don't ever say that. But did it fix itself? It did. If everyone refreshes, the new code is in place.
Yes, I could see that.
Sweet. All right, where was I? Need to go pull request to develop domain, create PR, and then merging will work. This is a great feature with infinite value. Infinity value. Infinite value. A comment, and we are, where is my merge button? Okay, so now main should have things in it. It does. We are going to reattempt to deploy from main. Definitely not, well, 24 bucks a month, huh? Nah, we don't need to do that. Try to save. Why is it $24 a month if it's on a $12 a month virtual machine? Oh, it must be HA. Okay. Um, sorry, HA, high availability. So it's going to be running two containers in order to make sure that the service stays up. Which actually in this case, oh yeah, okay. So you have to be on a minimum size. Whatever, don't care. We're going to still do the $5 a month because this is a demo. Type that right this time correctly. Demo. And unless I did something really silly, we will ship it. While that's going, 8 minutes. Yep, plenty of time. So what I would do now that we have a development environment and a production environment, development shipping from a branch, production shipping from main. Whenever I want to do anything else here, what I would do is something like feature, add a. So this is part of Git flow. You would create a feature branch, and then I want to add an image reference in app. A little bit of quick HTML. Oh my goodness. So Gemini just picked a random image to put in here, and I have no idea what that is, and that is definitely unacceptable. There's a dark part of me that really wants to know what that is. But instead, I am not going to do that. I'm going to put in a very tame picture of something related to teamwork. Neat. That should be it for the image tag. That looks like well-formed HTML. We will write it. Okay, now it needs a PR. So what I would do is then generate the PR to ship it to development. Doesn't really matter. And now that you have this branch that's in place, and once it's shipped, you would stop using it, right? Because then you can merge the exact same branch with the exact same code into main, and you can guarantee that the code stays the same. Or some people merge develop into main, depending on how many people are working on the team. So did production deploy? Production has deployed. And it says howdy. So what we would expect to happen now is a DigitalOcean build on Wes is playing with stuff. It's building. As I sit here impatiently. Watching logs scroll in real time is the best kind of Zoom meeting. Back to our rating. Do we have questions?
I'll say for those that are working on the Theo app or the Cap Metro, and as you're preparing to deploy, any quick questions or comments on your experience?
I have a quick question. When using the DigitalOcean app platform, if we have a project that is comprised of like a separate backend and front end,
Mhm.
would you recommend deploying them under the same app platform app, or would you recommend having separate apps for the front end and back end? Considering
Well,
that the project is a mono repo with both the front end and back end within the same GitHub
that is
repo.
the direction I was going to go. Do you control both sides of it?
Yes.
I would probably deploy them in the same project. I don't have a strong opinion though, but I would probably deploy it in the same project because you
Yeah.
get some networking benefits that way. They would be two different containers, so your YAML file would have multiple things. Um, and they let you choose a subdirectory to deploy from in the repo.
Yeah, and it lets you choose more than one subdirectory to deploy multiple things at once.
Yeah, I've never done that, but I feel like that would work okay.
Okay. Thank you.
Of course. I like those kind of questions. Feel free to, let's see, is it there? Great, we have an image. So at this point, we're out of time. I think everyone gets the point. Now you would take that feature branch that added an image to it, and you would either, and your whole team has to agree, this is the most important part, you would either always merge develop into main, or you would merge individual features into main. I tend to favor individual features, but you can end up with more merge conflicts that way. But if you've got 10, 20, 30 people working on feature or bug fix branches, I like to treat them as modules so that you can, unless they are tightly coupled inside of the software itself, you can ship my image change irregardless of whether someone else is shipping their gigantic database update kind of code.
I do have a question for Mr. Deviers.
It's Devers, but Wes is fine,
Yeah,
please.
I'm sorry, Wes. So for our project I'm working on, Cap Metro. So we do not have that big of a team. We have 5% in the back end, 5% big end. So do you still think we would need a development and main, two different deployments? Because right now, how our good branches are set up is that we have out of main, we have a dev front end and dev back end, and each will have its own branches coming out when they're working on feature. So do you recommend in a team this is of 10 people, do we still need a development, and then if development works, then we push into main?
I would always recommend that. Yes. But it also depends on where in the life cycle your software is, right? If you don't have active users, then I would only deal with development until you have active users, and then you at some point you switch and say, now we're in a production footing and we have to move to this different flow.
Okay. Okay, that makes sense. Thank you.
Alrighty. So we're right at the boundary of time, but I'd like to first thank Wes for the time, especially for the demo. Yeah, live demos are always a challenge, but you made it. It worked. We get the link, we get the app running, so that was awesome. Um, and I'd like to thank our mentors for being here as well in the presentation, students as well, early evening for being here and attending the demo. So yeah, I guess since we're virtual, a round of applause or some reactions in the chat to thank our presenter.
I just hope that someone found it useful and learned things. But thank you very much.
Absolutely, absolutely, more than ever, and we'll definitely have some follow up, and I do have some questions in here for students interested in even careers in your field. So I'm just gonna have them follow up with you if you don't mind us sharing your email, then we will and have them follow up with you.
Please do. Absolutely.
All
I'm
right,
technically on the Discord server, but
that's right.
I my full-time job is Slack and there's only so much chat I can deal with. So
Yes, yeah.
please email whenever you feel like it.
Email will be fine. And for the students, we have a form that I'll encourage all of you to fill out, like, provide your feedback and any other questions that you would like me to forward to Wes. So the link to the feedback form is in the chat, so you can quickly click on it before we end the call. With that being said, thank you, everyone. Have a good rest of your week and we'll hopefully see you on the next presentation. Goodbye.
Thank you everyone for listening. I appreciate it.